For the second question, we've got a large data table we need to put into the calculator. So we're going to go into the statistics mode to do that. Statistics mode here. I've got some numbers in mine already, so I'm going to have to delete those, delete all of those, and I'm going to delete all of those. And I'm going to put all these numbers going down here. I'm going to put 0, 1, 2 down this one here, and I'm going to put 7, 21, and 30, and the rest down there. Pause while I do that. As if by magic, so there they all are. I've tapped them all into the calculator. It did say 9 had none, so I haven't got a row of 9 or more there. So I've now put all the data in, and I can now use my calculator to go to my calculations, my one variable statistics. I always check n is 200 to make sure that, yep, we did put all of those in right. So I've got the mean of 3.64, and I've got a standard deviation here of 1.8869. Now I want to know what the variance is, so I could just tap that in there. You can actually get the variable back out again. It was there, wasn't it? So 1. And I want to square that, and so the variance is 3.5604. So there's the mean and the variance. Suggest why the answer's in part A. So explain why it will be a suitable model. Same thing as this before. Look, these two things are very similar, and so we would say that a Poisson model would be suitable. And then part C, using a suitable value for mu, probability that 2 cars will pass in 5 minutes. So these are all 5 minutes. So X is a Poisson. What should we use? Let's use 3.6. They both round to 3.6, don't they? And we want no more than 2. No more than 2. So less than or equal to 2. Menu into the distribution menu now. The Poisson, no more than 2 with a mean of 3.6. So that looks like 0.303. As I work through that, compare your answer in part C with the relative frequency of obtaining no more than 2 cars from the table. So in the table, we've got 0, 1, or 2 cars. They're the ones that we're interested in. That's 7, 21, and 30. So that's a grand total of, what's that, 58, isn't it? So 58 out of 200. 58 out of 200. What's that as a decimal? 58 out of 200 is 0.29, isn't it? So 0.29, compare that with the 0.3 you had before. It's very similar. So the model gives a probability of 0.303. The actual data gives a relative frequency of 0.29, and they're very close. So that is a good supporting piece of evidence to say that a Poisson is the right model for them.